Hi everyone, welcome to the last lecture of this module. Today we will discuss some important features in C++. This is the agenda. Now that we understand something about classes, objects, and pointers in C++, we should dwell deep into the advanced functions of C++. This lecture we will cover a loosely related topic collection for subjects like friend functions, inline functions, the this pointer. All these are advanced features. They are not necessary for every C++ program, especially very short ones. However, they are widely used and are essential for most full programs. Also, this lecture introduces templates and exceptions. Templates make it possible to use one function or class to handle many different data types. Exceptions provide a convenient and uniform way to handle errors that occur within classes. So today we will look at function templates first, then go to class templates, and finally to exceptions. So let's begin. First we will start with default arguments. So a default argument is a value that is used automatically if you omit the corresponding actual argument from a function call. So as the name suggests, if needed, we can provide a function with default values for its arguments. So if no value for that argument is passed during function call, function will take default value for that parameter. If no value for that argument is passed during a function call, function will take the default value for that parameter. The question is, how do you establish a default value? We must see the function prototype because the compiler looks at the prototype to see how many arguments a function uses. The function prototype also has to alert the program to the possibility of default arguments. The method is to assign a value to the argument in the prototype itself. So when we use a function with an argument list, you must add defaults from right to left. That is, you can't provide a default value for a particular argument unless you also provide default values for all the arguments to its right. So in this example, if you see carefully, function void test is having two arguments. But if you call it without arguments in C language, it will give compilation errors because no arguments are passed. Let's see how this will work in C++. So this is the same function. Here no arguments are passed. I is equal to 10 and f is equal to 2.0 will be the corresponding values of I and f. Second case, when we are passing only one argument. So the first argument is passed. The value of I will be equal to 1, not 10 here because it is given. But there is no argument for f, float f. So the value of f will be equal to 2.0, which is defined in the prototype. Next, we have two arguments here. Hence, value of I will be 1 and value of f will be 1.1 as the values are passed in the function call. So both the values, if they are passed in the function call, that value will be assigned. But if they are not passed, then the default value defined in the prototype will be assigned. Now, another way, suppose we call the second argument only, like how it is called here. We are calling only test 1.1. So it will be a error because the actual arguments are assigned to the corresponding formal arguments from left to right. You can't skip over arguments. So the arguments are assigned from left to right. If you are skipping one argument, it will be a error. Thus, default arguments are not a major programming breakthrough, but they are a convenience. When you begin working with a class design, you will find that they can reduce the number of constructors, methods, and method overloads which you have to define. So the default arguments will take the default value as defined in the function prototype. This is very convenient in C++. Now we will discuss about this pointer. So the memory functions of every object have access to a sort of magic pointer which is named as this. It points to the object itself. Thus, any member function can find out the address of the object of which it is a member. It will be able to find out the address of the object of which it is a member. When you call a member function, it comes into existence with the value of this set to the address of the object for which it was called. So the this pointer can be treated like any other pointer to an object and can thus be used to access the data in the object it points to. So this pointer is like a normal pointer only, but it can be used to access the data in the object where it points to. So this pointer is not available in static member functions. As static member functions can be called without any object with class name. So it is available as a local variable in all the non-static functions in a class. It is not available in static member functions as they can be called without any object. It holds the memory address of the current object. So if you see this example, here this class consists of a private array of 10 bytes and public function void reveal. Now in the main program it creates three objects of type where. So where is the name of the class. Three objects are created, W1, W2 and W3. It then asks each object to print its address. So each object is asked to print its address using the reveal member function. Now this reveal member function, if you look carefully, prints out the value of this pointer. My object's address is, then it is printing out the value of this pointer. So this pointer will be pointing to the address of the current object. So the output of this will be something like this. So the data in each object is an array of 10 bytes. Hence, the objects are spaced 10 bytes apart in memory. If you see the object's address, they are separated by 10 bytes. So we can access the data members using this pointer. It can be used to access the data in the object to which it points. Another practical use of this is in returning values from member function and overloaded operators. So we can return the values. To return the object itself, it can be used like pointer to this. When we write this, it is giving the address. When we give pointer to this, it gives the data itself. This is very important, this pointer. Moving on to the next topic, inline functions. When the compiler sees a function call, it normally generates a jump to the function, correct? This sequence of events may take extra time. To save the execution time in short functions, you may elect to put the code in function body directly in line with the code of the calling program. That is, each time there is a function call in the source file, the actual code from the function is inserted instead of a jump to the function. So instead of taking a jump to the function, the code is copied when we use inline functions. Any function with a definition in the class declaration automatically becomes an inline function. Just add the keyword inline during with the function definition. The inline function is written like a normal function in the source file but compiles into inline code instead of into a function. So, the source file remains well organized and easy to read since the function is shown as a separate entity. However, when the program is completed, the function body is actually inserted into the program wherever a function call occurs. Functions that are very short, say one or two statements, are candidates to be inlined. So, suppose some of our functions are very small due to which the function call will result in degraded performance. For example, int square int a, return a into a. This just contains one simple computation. So calling it as a new function just adds to the overhead of the function call and hence degraded performance. Thus, using inline function, we can reduce the execution time. In an inline function, the compiled code is in line with the other code in the program. That is, the compiler replaces the function call with the corresponding function code. So if you see this example, here the function call is happening. Every time the function call is happening, a regular function will transfer the program execution to a separate function. But in an inline function, every time the code is copied into the function. So with inline code, the program doesn't have to jump to another location to execute the code and then jump back. Inline functions run a little faster than regular functions, but they come with a memory penalty. If a program calls an inline function at 10 separate locations, then the program winds up with 10 copies of the function inserted into the code. Also, you should be aware that the inline keyword is actually just a request to the compiler. Sometimes the compiler will ignore the request and compile the function as a normal function. For instance, it might decide that the function is too long to be inline. Here there is one more example of void multiplication table. So every time multiplication table function is called, the code will be copied there. So a regular function transfer program execution to a separate function, it jumps to a particular location, whereas an inline function replaces the function call with inline code. Now we'll discuss about friend functions. The concepts of encapsulation and data hiding says that non-member functions should not be able to access an object's private or protected data. Non-member functions should not be able to access an object's private or protected data. So if you are not a member of the class, you cannot get in. However, there are situations where such rigid discrimination leads to considerable inconvenience. Suppose a function wants to operate on an object of two different classes. The function will take object of the two classes as arguments and operate on their private data. The function will have to take objects of the two classes as arguments and operate on their private data. In this situation, there is nothing like a friend function. Friend can directly access the private data. It is more efficient without any overhead. So, we will see one example to understand this. If you see this class distance, the set distance function is a friend function. It is defined outside the class. So, we can define it outside the class only if it is defined as friend function. It can access the private data, that is int meter, because it is a friend function. So we can declare such functions inside other classes also if they are friend functions. Now we will discuss about very important advanced feature of C++, templates. Suppose you want to write a function that returns the absolute value of two numbers. We know that the absolute value of a number is its value without regard to its signature, with its sign. That is, the absolute value of 3 is 3 and the absolute value of minus 3 is also 3. Consider writing a function in C++ for this. It would be written for a particular data type. So, the function is defined to take an argument type and then return its value. So, in this particular one, we are defining the argument type as int and return a value of int. That is absolute. Now, suppose you want to find the absolute value of type long. You will need to completely write a new function which is having long argument and long return value. Again, for type float, similarly you have to do. So here, even though our code is same for all the functions, we need to write it again and again to get this functionality for different data types. This is where templates come for help. The function templates can be used to represent the data type used by the function, not as a specific type such as int, but as a name that can stand for any type. So it can be used to represent the data type used by the function, not as a specific type, but can stand for any type. The template keyword signals the compiler that we are about to define a function template. We are about to define a function template. Instead of rewriting the same function body over and over for different types, which is time consuming and waste space, we can use templates by writing a function just once and have it work for many different data types. Also, if you made an error in one function, you need to remember to correct it in each function body. Whereas using a function template, you need not do that. As object-oriented programming concentrates on data types, generic programming concentrates on algorithms. Using generic programming, we can write the code which is independent of data types. Templates are the C++ tools for creating generic programs. Let's see some examples. So we have seen that the absolute function, when used for different data types, we have to write differently. Now we will see how it will work with multiple data types. The first line, starting with the keyword template and function definition following, is called a function template. So it is starting with the keyword template and the function definition is following. So it is called a function template. In this function template, the name is T, capital T. The template keyword signals the compiler that we are about to define a function template. The variable following the keyword class is called the template argument. Here, because you have declared it as a template, the compiler understands it is a generic function, and according to the function call, it will change the variable, that is capital T here, to corresponding data type. Only thing to note is whatever operation you do in this should be supported by the input variable during function call. So this is the syntax for template. This is the name of the generic type. Suppose we want to pass two generic arguments. Then we can declare multiple templates and use those names in parameter list. Then all these function calls are valid. We are calling different types of values like int or float or double. All are valid and returns correct result. How does the compiler do this? So the question is, what does the compiler do when it sees the template keyword and the function definition that follows it? Well, nothing right away. The function template itself doesn't cause the compiler to generate any code. It can't generate code because it doesn't know what data type the function will be working with. It simply remembers the template for possible future use. Code generation doesn't take place until the function is actually called or invoked by a statement within the program. When the compiler sees such a function call, it knows that the type to use is int because that is the type of the argument. So it generates a specific version of the absolute function for type int, substituting int wherever it sees the name t in the function template. This is called instantiating the function template, and each instantiated version of the function is called a template function. Similarly, the expression apps long causes the compiler to generate a version of apps that operates on type long, and while the apps double call generates a function that works on type double. Of course, the compiler is smart enough to generate only one version for each data type. Even though there are two calls to the int version of the function, the code for this version appears only once in the executable code. Now, the template concept of function can be extended to classes. Class templates are generally used for data storage classes. Same way we create a new template and use it instead of the data type during declaration. Here the class stack is presented as a template class. So template in bracket class and type. Okay. This approach is similar to what we saw in function templates. The template keyword and class stack signal that the entire class will be a template class. Now, a template argument named type in this example is then used. Instead of fixed data type, for example, int, here argument type is used every place in the class specification. So, wherever there is a reference to the type of the array, that is type st, this will be used. Here there are three such examples: at the definition of st, at the argument type of the push function, and the return type of the pop function. So instead of using int or any particular data type, the template class type is used there. Now, the expression template class type must precede not only the class definition but each externally defined member function as well. So wherever it is defined, it is included. Template class type expression should be included wherever the member function is defined anywhere else. Next, class templates differ from function templates in the way they are instantiated. So, to create an actual function from a function template, you create it using arguments of specific type. So here these are defined inside class. Class functions are defined outside class. Each time you need to specify the template syntax before the function. Every time you have to specify that. Then classes, however, are instantiated by defining an object using the template argument stack float s1. So to instantiate the class, we have to define an object. To create an actual function from a function template, you call it using an argument of specific type. However, classes are instantiated by defining an object using the template argument, that is stack float s1. This is how class templates are instantiated and then used. Now, exceptions. Exceptions provide a systematic, object oriented approach to handling errors generated by C. Exceptions are errors that occur at runtime. They are caused by a wide variety of exceptional circumstances. For example, running out of memory, not being able to open a file, trying to initialize an object to an impossible value, or using an out of bound index to a vector. To handle such situations, exception handling is introduced in C++. Imagine an application that creates and interacts with objects of a certain class. Ordinarily, the application's call to the class member function causes no problems. Sometimes, however, the application makes a mistake, causing an error to be detected in a member function. This member function then informs the application that an error has occurred. When exceptions are used, this is called throwing an exception, that is informing. In this application, we install a separate section of code to handle the error. This code is called exceptional handler or catch block. This is called catch block. It catches the exception thrown by the member function. Any code in the application that uses object of this class is enclosed in a try block. So errors generated in the try block will be caught in the catch block. Code that doesn't interact with the class need not be in a try block. So we have three types of blocks: try block, catch block and throw block. The suspected code is enclosed in a try block. A catch block is executed if exception occurs. A throw block is used to inform the parent function that exception has occurred, an unexpected situation has occurred. So the parent function will decide whether the exception is to be handled or not. So if you see this example, try block, catch block and throw block, all three are there. So this is the syntax for catching the exception with parameters. In this case, we are using char star parameter. This is the syntax for catching all types of exceptions. Let's see one example. So input is 4, 2. Output will be 2. The program completed will be printed and it will exit. Now another case where the input is 4, 0. It will go into throw, that is second number cannot be 0 and error will occur. So it will exit. Note that the statements that were present after the exception happened were not executed. Program completed is not printed, whereas the statements after try blocks are executed. So this is how exception handling is done. This completes our module on C++. So we have discussed in detail about objects and classes. We discussed about several object oriented programming concepts in C++. We saw various types of inheritance, the different types of specifiers, base class, derived class, and how inheritance occurs. Then we saw polymorphism, how different types of overloading occurs, function overloading, operator overloading, function overloading where the function arguments can be different, operator overloading where the same operator can be used for user defined data types. Then we saw some important features, for example, templates, exception handling, and this pointer today. So, this will give you a brief introduction to go ahead with C++. Any more details, you can refer the books mentioned. All the best. Thank you.